Okay, we're to solve this linear system, but we only want to find x. They only asked us what x was, so we don't have to find y and z also. Well, to begin with, I would want to get rid of these decimals by multiplying the top equation times 100, the middle equation times 10, and the third equation times 100. And that gets rid of all the decimals. But looking at this, I noticed that all the coefficients in the second two equations were divisible by 2. But dividing each of the second two equations by 2 makes the numbers even smaller and more manageable. So we end up with this system of 3 equations and 3 unknowns. These 3 planes are the same 3 planes as described by the first equations. So to solve this using Cramer's rule, we first have to find d. So finding d, we have the x column, the coefficients of the x's in the 3 equations, 1, 11, and 0. The third equation has no x term, so it's 0 x's. The second column is 2 and negative 7 and 1, the coefficients of y in the 3 equations. And for the z column, we have negative 3, 4, and negative 4. Copying the first 2 columns, 1, 11, 0, 2, negative 7, 1, we can begin our diagonal multiplies here. So 1 times negative 7 times negative 4 is positive 28. We have 2 times 4 times 0. That makes this one just 0. And then we have negative 3 times 11 times 1. That's negative 33. And subtracting the diagonals going the other way, we have 0 times whatever will give us 0. The second column is 1 times 4 times 1, which gives us 4. And the third column is negative 4 times 11 times 2. That's like negative 8 times 11, negative 88. So 28 take away 33 is negative 5. And we're subtracting from negative 5, well, negative 88 plus 4, 4 minus 88 is negative 84. Negative of a negative 84 is plus 84. So d ends up equaling 84 minus 5, which is 79. So there's the d for this, this linear system. And since they're asking us for x, we only have to find d sub x, and we'll be done. So find d sub x. So this time we put 0, 5, 2, what's on the right side of the linear systems here, of all 3 equations. 0, 5, 2 will cover the x column. The y column will be the same as before, that 2, negative 7, 1. And the third column is negative 3, 4, negative 4. And now we'll copy the first 2 columns to the right of this matrix. We don't need that anymore. We just need to put what d equals over here so we can make use of it later and I'll have the space. Okay, copying the first 2 columns, we have 0, 5, 2, and 2, negative 7, 1. Okay, so multiplying the main diagonals, the first one is 0 times whatever, gives us 0. The second one is 2 times 4 times 2, which gives us 16. And finally, negative 3 times 5 times 1 is negative 15. And then subtracting the diagonals going the opposite direction, we have 2 times 7 times 3 is 42. We've got 1 times 4 times 0 is 0. And we've got negative 4 times 5 times 2 is negative 40. So d sub x here is equal to 16 minus 15 is 1, minus 42 minus 40 is 2, so minus 1. Therefore, we know what x is. X is equal to d sub x divided by d which in this case is -1 divided by 79. So x is equal to -1 divided by 79 is our solution for this one.